Okay, hello students, welcome back. We're going to cover 2.3 and 2.4 today, percentiles and quartiles, and we're going to create some box plots. Okay, so let's get into it. Share my screen here. Okay. Okay, so the objectives today: calculate and interpret the percentile of a value, find the value at a given percentile, calculate the 5-number summary, the min, the Q1, the median, the Q3, and the max of a data set, create and interpret box plots, identify outliers using the 1.5 times IQRL rule. Okay, those are called the fences. We'll get into that. Okay, percentile. A percentile is a measure of location. A value at the kth percentile cuts off the lower k% of the values. In other words, a score is higher than k% of all data values, and k% is located to the left of the value. For example, the 50th percentile is a cutoff point for the lower half of the data. Okay, so 50% of the data is lower than the 50th percentile. If you are in the 50th percentile, then at most 50% of the values are lower than your value. This point is commonly known as the median. In this case, the 50th percentile is the median. It's just a special name for that percentile. Okay, finding the percentile of a value. Percentile of value is the number of values less than X divided by the total number of values times 100. Okay, that'll give me my percentage. Okay, the scores of 40 bowlers in a league reported their score from the most recent game. The score report is below. Okay, so the scores are reported below. So we have 40 of these scores, four rows of 10. It says find the percentile of a bowler in the league who scored 150 points. Okay, so we have 150 points here and 150 points here. Okay, so we want to find the percentile. So we want to know what are the number of values less than 150. What are the number of values less than 150? Well, it's the whole top row that's less than 150. So there are 10 of them. So there are 10 out of 40 that are less than 150. And so 10 divided by 40 is 0.25 times 100 is 25%. So we would say that's the 25th percentile. 150 is the 25th percentile. Okay, that means 25% of the values are less than 150. Okay. Okay, what about 278 here? Okay, 278. We've got a couple of those. How many values are less than 278? Well, there's 3 rows and then 3 items. Okay, 3 rows and 3 items here that are less than 278. So 3 rows is 30 plus 3 items is 33. So that's 33 out of 40. Okay, 33 out of 40 that are less than 70. I'm going to put a barrier there. It says, hey, it's less than 278. So if I were to divide this on a calculator, 33 divided by 40, I would get 0.825. So that's 0.825. Multiply that by 100, and I get 82.5%. Okay, so I generally want to round this up. Okay, so I want to round this up. And so I would say that this is approximately the 83rd percentile. 83rd percentile. Okay. Okay, suppose we wish to find the data points that cut off k% of n values. Okay, how many, what are the data points that cut off k%? Okay, we have to find the data point's position in the list of values. So L is the location, equals the number of values we need to cut off, okay, equals k% times n. N is the number of values there. Okay. Sometimes we use I instead of L to represent the location or the index. Okay. The number of values, if the number of values is a whole number, then the cut is in between the data values. Okay. If the number of values is a whole number, then the cut is in between the data values. If the number is not a whole number, then we select the data value, the next data value up. We always go up to the next data, because we want to ensure that it's less than, right? That the 83rd percentile is less than. So we would go up to the next value here. Using the table from example 1, find the 5th percentile. Okay, so let's try to find the 5th percentile here. So the 5th percentile is going to be 0.05 times 40. Okay, times 40. And that is equal to 2. Okay, so we're going to look at what are the two values that are lower. Or there's going to be two values lower than the value we're looking at, right? So it says, so that's a whole number. It's a whole number, right? So we're going to look at basically the second value. Okay. So we cut between the data values, cut in between the data. If the data values is a whole number, and we cut in between the data values. Okay, so how does this work? So let's go up here. Okay. So the first data value here is 98. The second data value is 100. And the third data value is 100, right? So if it's a whole number, we're going to cut right in between the second and third values. And we say, oh, well, there's a cut there. There's an even cut right there. Okay. And so we would average those values. Okay, we would average the values 100 and 100, and we take the average of that, and that would be our 5th percentile. Okay, that's how we would get our 5th percentile. We would say, okay, let's average the second and third value. Average the second and third values. And so that's 100 plus 100 over 2. Second value is 100. The third value is 100. And we're going to divide that by 2. And so it's just 100. Okay, so 100 is the 5th percentile. Okay, 100 is the 5th percentile. Okay. I'm just going to put 100 because that's what we're answering. We're answering 100 is the 5th percentile. Okay, let's look at B, the 21st percentile. So what would be the 21st percentile? Okay, so we're kind of going backwards here. We're saying, what would be the 21st percentile? Okay, so what over, what value over 40 would give me the 21st percentile, right? So it's kind of say, well, what value over 40 would give me the 21st percentile, or 0.21, right? So we're going to multiply 40 times 0.21, and that gives me 8.4. And now again, I'm going to go to the next value. If the value is not a whole number, criteria number 2 here, if the value is not a whole number, then I go up to the next value. Okay, I go up to the next integer. So the next integer here is 9. Okay, so this is 9. So I would say that 9, okay, 9 is the ninth value. Sorry, the ninth value is the 21st percentile, is the 21st percentile. Okay, so what is the ninth value? Okay, so the ninth value is going to be 145. Okay, so the ninth value there was 145. Okay. Okay, so the 145 is the ninth value. Okay, so what's the 21st percentile? So the ninth value, which is 145. Okay, what about the 90th percentile? The 90th percentile, 0.90, okay, times 40 is equal to, what is that, 36? 36, which is a whole number. So I'm going to look at the 36th and 37th items. So we want to average the 36th and 37th items, okay, in our data set. Okay, so what's the 36th and 37th item? Okay, well, going from the back, this would be 40, 300 would be 40, 39, 38, 36, and 37 looks like 280 and 281. Okay, that's the 36th and 37th item. So I want to average those values. 280 and 281. So 280 plus 281 over 2. That's going to be 280.5. And so 280.5 is my 90th percentile. Okay, that's the 90th percentile. That means that 90% of the data values are below 280.5. Okay, 90% of the values are below 280.5. Okay, what about the third quartile? What's a quartile? Well, it's a quarter. So what's 3/4? What's 3/4 of a dollar? Well, it's 75 cents. 3/4 is 75 cents. So that's the quartile. So 0.75 out of 40 is 30. So here I want to average the 30th and 31st items. Average 30th and 31st items. Okay, so what are those? What's the 30th and 31st item? It looks like 269 and 270. No, not that's 260 and 269 are the 30th and 31st. So I'm going to average those guys. Okay, 260 plus 269 over 2 is equal to, let's go to the calculator on this one. 260 plus 269 is 529 divided by 2 is 264.5. 264.5. Okay, so 264.5 is the third quartile, or the 75th percentile. The third quartile is the 75th percentile. Okay. So what does that mean? That means 75% of the values are below 264.5. Okay, are below 264.5. And is that right? Is that right? If I were to write 264.5 here, are 2/3 of the values below that? Yeah, because I would have 30 values out of a total 40, and 30 out of 40 is equal to 0.75. So yeah, 264.5, it's a great number to use there because it means that 260 is less than that one. Okay, we don't want 269. We don't want to use 269. We're going to use 264.5, which forces it to be less than 3/4 of the values. Okay, so sometimes one number is not enough to summarize our data. Measures of center, such as mean and median, alone cannot describe our data in a bigger picture. Remember, mean is the average, and median is the middle number, okay, or the 50th percentile. Okay, sometimes we need more numbers to give us a more descriptive summary of what the shape of our data looks like. One way to get a bigger picture is to look at the 5-number summary. Okay, the minimum, the Q1, which is the 25th percentile, the median, the Q3, the median, which is the second quartile or the 25th or the 50th percentile, Q3 or the 70th percentile, it's the median of the upper half, and the Q1 is the median of the lower half, and then the maximum. So we have these 5 numbers. So we want to calculate the 5-number summary here. Okay, so how are we going to do this? Okay, well, we want to find the minimum value first. So the minimum value is 2. That's the smallest number. Okay. What about Q1? They said that it's the 25th percentile or the median of the lower half. It's the middle of the lower half. Well, there are 10 numbers here. If I just look at the top half of the data set, what's that middle number? Well, it's 5. Okay, 5 is the middle number there. Okay, it's right in the middle. It's the median or the middle number of our data set. Okay, or what we would call the 25th percentile. Okay, so this thing, the Q1, which we call the first quartile, Q1 is equal to 5. Okay, so we don't have to do any calculations. We just look at the data set and say, okay, the middle of the upper half. Now, what if there wasn't a middle of the upper half? Well, we would find the average of the two. Okay, and that's how we would get the middle number. We would average the two middles. Okay, what about the median, or sometimes they call that Q2? The median. What's the median? Well, the median is the middle. Well, there is no middle here. There's the 5th value and there's the 6th value, but there is no middle. So in this case, I do have to do the average. I have to average the 5th and the 6th value. There is no middle in the whole thing, The median is going to be 6 plus 8 over 2. That's 14 over 2, which is 7. So the median is 7, which is the 50th percentile. Okay, so that's the 50th percentile there. Okay. Okay, what about Q3? What's the middle of Q3? What's the middle of the upper half? Here's the upper half. Okay, and what's the middle of the upper half? Well, it's 11. The middle of the upper half is 11. Okay. And so now we just want the maximum. What's the maximum? The maximum value was 14. Okay, the maximum value was 14. So there's our 5-number summary. And later on, this is going to help us create something called a box plot. Okay, find the 5-number summary for the following data set. Okay, 10, 13, 14, 18, 22, 23, 23, 23, 25, 30, 32, and 31. Okay, here we don't have just 10 values, we have 12 values. Okay, so here, let's do the minimum again. The minimum, what's the minimum? The minimum is 10. What's the maximum? Yeah, the maximum is 51. What's the median? Yeah, let's do, well, let's not do the median. Let's do the Q1. What's the middle number of the top half? The middle number of the top half. Well, there is no middle number, but there are two middle numbers. Okay, 14 and 18. So we're gonna add those together and divide by 2. And when I do that, I get 16. So Q1 was 16. What about the median? The median. Well, in 12 numbers, there is no middle number because it's even. If it's odd, you have a middle number. But if there's an even number of data points, you don't have a middle number. So I'm going to use 6 and 7. So this is going to be 23 plus 23 over 2, which is 23. Okay, so the median there was 23. Okay, what about Q3? Q3 is the middle of the upper half. Well, the upper half is the bottom row. And so the middle, there's not just one middle, there's two middles for the lower half, for the upper half, I should say. 25 plus 30 over 2. Okay, so that becomes 55. Divide that by 2. I get 27.5, and that's Q3. So that's my 5-number summary. Okay. Okay, a box plot graphically displays a 5-number summary. Steps to creating a box plot by hand. Find the 5-number summary. Okay, check. Draw a scaled axis to fit the maximum and minimum and scale it accordingly. Draw lines above the axis matching each summary value and draw a box around Q1 to Q3. Draw whiskers out to the minimum and maximum values. Okay. So let's follow these directions, all these directions, and we're going to create a box plot. Okay. Move it down a little bit. Okay, let's follow the directions here. So first, 5-number summary. Okay, so this is the same data set as in the from data set 5A, or I guess it would be 3A. Yeah, it'll be 3A. That should say 3A. Sorry, I have to go back and change those in my notes. Okay, as in 3A, 2, 4, 5, 5, and we got the 5-number summary already. We calculated that, so that's good. It's 2, 5, 7, 11, and 14. Okay, so now it says draw a scaled axis to fit the maximum and minimum. So we want to go all the way from 2 to 14. So what I'm going to do is I'm going to go by 2s. I'm going to go 2, 4, 6, 8, 10, 12, 14. And that should encapsulate all the data values that I need. Okay. Now it says draw lines above the axis matching each summary value. Okay, so draw lines above the axes matching each value summary. Okay, so draw lines. Okay, so I don't know. Let's see. Draw lines above the axes matching each. Oh, okay. So here's what it means. It means draw a line. I'm assuming a vertical line above each of these. Okay. 2, 5. Where would 5 be? It would be here. Okay. And then 7 would be here. And then 11 would be here. And then 14 would be here. Okay. Okay. I'm going to draw those lines. Okay. Perfect. Now, it says, draw a box around Q1 to Q3. Okay, so we want a box Q1. Well, what was Q1? It was here. So this is the min, Q1, Q2, well, I'll call that the median, Q3, and the max. And we want to draw a box from around Q1 and Q3. Okay, so draw a box around Q1 to Q3. Okay, good. Okay, and then it says draw a whisker. Okay, draw whiskers out to the minimum and maximum values. So whiskers are going to look like this. Okay, and out like this. Okay, so there you go. There's your box and whisker plot. Nice. Okay. Okay, so here's the set of data from example 3B. Okay, so we have 10, 16, 23, 27.5, and 51 is our 5-number summary. So let's try doing this again. Okay, so we're going to go from 10 to 51. So maybe I want to go by 10s this time instead of 2s, right? I want to make sure that this doesn't get too, the scale doesn't get too big. Maybe we'll go 10, 20, 30, 40, 50, 60. 10, 20, 30, 40, 50, 60. Maybe I could spread this out a little bit more. So 10, 20, 30, 40, 50, 60. 10, 20, 30, 40, 50, 60. Okay. And so what's the minimum? The minimum was at 10. Okay, nice. The maximum was at 51. Okay, maximum at 51. Okay, where was Q1? Q1 was at 16, so that's going to be about here. Okay, Q2 was at 23, that's about here. Okay, I'm just kind of eyeballing it, doesn't have to be incredibly accurate. Okay, and then 27.5, that's less than 30, but bigger than 25. Okay, 25 would be like right there, right? So it'd be like halfway in between. And so now what we do, we have this is Q1, this is our median, this is Q3, this is our maximum, and this is our min. Right, and so we want to draw a box between Q1 and Q3. We want to box Q1 to Q3, and then we want to draw our whiskers. Okay. Okay, there's our box and whisker plot. Okay, box plot shapes. Okay, although much of the data values are not apparent, you can still look for the following features in your box plot. Is it symmetric or is it skewed? Is the box in the middle or is the box to one side? Okay, is it symmetric? Okay, is it balanced or is it skewed? You know, are there a lot of values in the lower half or a lot of values in the upper half? What's the IQR, right? What's the IQR? Well, what the heck is an IQR? Well, the IQR is the interquartile range. Interquartile range. Okay, and so what's the interquartile range? Well, the interquartile range is the range between Q3 and Q1. So the IQR is Q3 minus Q1. And sometimes that range can be really big, and sometimes that range can be really, really small. This is the sides of the box. These are the length of the sides of the box, we'll say. These are the length of the box. We don't even have to worry about the size. It's just the length of the box. Okay, up here, for our previous example, our example 4, we had for A, we had, you know, the box went from say 5 to 11. Okay, so that was the length of the interquartile range, was Q3 minus Q1, which is 11 minus 5, so a length of 7. Okay, so the box has a length of 7 there. Here, the box goes from 16 to 27.5. So what's the length of that box? 27.5 minus 16. Okay, this is the IQR. Okay, and so the IQR there is going to be 11.5. Okay, so even though graphically it looked like it was a smaller box, that's just because the range of values that we're going through is a lot bigger. Okay, it's 11.5 is the interquartile range. Okay, for that one, the interquartile range here was 7, 11.5 and 7. Okay, how do we find outliers? Okay, what is an outlier and how do we find them? Well, in order to define an outlier, it has to be at least 1.5 times farther from the median than or farther from the quartiles. Okay, and that length is 1.5 times bigger than the IQR. Okay, so let me draw a picture because I think that will make it a lot less confusing. So if I have, say, Q1 here, and I have Q3 here, I'm going to find the interquartile range, okay, the IQR. And then I'm going to figure out, okay, I'm going to multiply 1.5 times the IQR. I'm going to take one of these boxes, okay, and I'm going to add it here. And then I'm going to take another half box. And if my data point is outside of that, that's an outlier. Okay, that's an outlier. We take 1.5 IQRs above Q3, it's an outlier. And if we have 1.5 boxes below, okay, 1.5 boxes below, that's also an outlier. Okay, and what we call this 1.5 boxes here is we call these our fences. Okay, think of it like, swinging for the fence and getting beyond the field in baseball. You're hitting a home run, then what happens is you go outside the fence. Okay, you go outside the baseball fence and you hit a home run. And these outliers are outside these fences. Okay, this fence is 1.5 IQRs below Q1, and this fence is located 1.5 IQRs above Q3. Okay, and we call this the upper fence, or the UF, and we call this the lower fence, or the LF. Okay. Okay, and these points are considered unusual. They don't behave like the rest of the points, and they're outliers. And usually an outlier will be starred. Won't be a point, won't be a slash, it'll be a star. And you'll be like, okay, you're the stars, you're the odd ones. Okay. And that's an outlier. It's just data that doesn't fit the rest of the data set. Okay. It doesn't behave like the rest of the data set. So sometimes we throw out outliers. We're like, hey, that's just a really odd data value, and it's going to mess up my statistics, so I'm going to throw it out. Or maybe an outlier tells you that there's something going on here, that, hey, there's maybe 2 different populations inside the same group of data. Okay, let's do a modified box plot with outliers here. Okay, modified box plot with outliers. Consider the same example, okay, that we did before. But now we want to identify any outliers, okay, using the 1.5 IQR rule. Okay. So first we're gonna let me go back to red here. First, we're gonna say, okay, what is the IQR? What's the interquartile range? Well, the interquartile range, we calculated that already. That was Q3 minus Q1. That was 27.5 minus 16, which is 11.5. So we calculated this already. Okay, and so we want to know, okay, well, from Q3 plus 11.5, Q3 plus 11.5, where's our upper fence? Okay, this is going to be our upper fence. Is Q3. Well, what was Q3? Q3 was 27.5, right? So this is 27.5 plus 11.5, which when I calculate that, or sorry, it's 1.5 times 11.5. It's Q3 plus 1.5 times the IQR. Sorry, I don't want to just go up an IQR. I want to go up 1.5 times the IQR. So this is equal to 27.5 plus 1.5 times 11.5. Okay, so let's plug that into a calculator. Let's pull my calculator up here. Oops, wrong calculator. Okay, let's pull the calculator up here. Come on, be kind to me. Okay. Let's pull that guy over. Okay, so 27.5 plus 1.5 times 11.5 equals, and I'm getting 44.75. So this is my upper fence. Okay, so any value that's beyond 44.75 is an outlier. Do I have any values beyond 44.75? Do I have any values in my data set that are bigger than 44.75? And yes, I do. It's 51. So this is an upper outlier. Okay, you, sir, are an outlier. Okay, you're an upper outlier. What about my lower fence? Well, that's Q1 minus 1.5 times my IQR. Okay, and so this becomes Q1 is 16 minus 1.5 times 11.5. Okay, my IQR was 11.5. So then I'm going to multiply this, or I'm going to do the calculation of this. 16 minus 1.5 times 11.5. Okay, that's negative 1.25. Okay, and since I don't have any negative values here, I don't have any lower lower outliers. So if I were to look at the value again, okay, if I were to look at the values again at this box plot, here's how I would do the box plot. See, the outlier means that we have to change our whisker. Okay, we don't consider the outlier the max now. What we consider the max is the highest non-outlier, and that's 32 now. So 32 is our new max. Okay, that's our new max. We kind of throw out the outlier. We're going to include it in our graph, but our new max is 32. Okay, well, here's how this works. So we're still going to go 10, 20, 30, 40, and 50, and 60. Maybe I'll spread it out a little bit more like I did last time. 10, 20, 30, 40, 50, and 60. 10, 20, 30, 40, 50, and 60. Okay, and so what's our minimum? Our minimum is 10. What's our new maximum? Our new maximum is 32. That's right there. Okay, and then what's our Q1? Our Q1 is 16, so that's going to be right here. Our median is 23, so that's right here. Okay, and our 27.5 is our Q3, so that's right here. And then I'm going to draw my box and my whiskers. Okay, so you can see that the box and whisker plot now is a lot more symmetric. Okay, it's a lot more balanced. Okay, but we still need to put in our outlier. Well, where was our outlier? Our outlier was at 51. So we're going to do a star there at 51. Okay, maybe closer to here. Okay, we're going to do a little star, and it tells me, look, you have an outlier. Sometimes it's a star. Sometimes they do an open circle. Okay, however you want to do it. Let's finish up by interpreting some box plots. They're going to give us a box plot. We just have to interpret it. Okay, what's the box plot tell us? Above each line on the box plot below, write what the line represents. Okay, what percent of the data is below the number 12? Well, this is Q1. Q1 is 12, so 12, Q1 is my first quartile, in quarter, right? First quartile, quarter, which is 25 cents, which is 25%. So this is my this is 25%. 25% of the data is below 12. Okay. What percent of the data is above 19? Well, 19 is my maximum. So is below 19. 19 is my maximum. So 100% of the data is below 19. 100%. Okay, let's look at the next ones. Okay, use the box plot below to answer the following questions. We have a construction worker and a teacher. If you make $30,000, that's what 30K means, $30,000, you make more than what percent of teachers? So if you make 30,000 here, okay, then you make more than 25% of teachers, right? You make more than only 25% of the teachers make less than 30,000. Okay, that's those people here. 25% of teachers make less than 30,000. Okay, so 25% there. If you make 30,000, you make more than what percent of construction workers? 0. No construction worker is getting paid less than 30,000. Okay, so that's 0%, according to this chart. Maybe this is in New York City or something, who knows? Okay, if you make more than 50% of construction workers, you make what percent of teachers? Okay, so the 50th percentile for construction workers is here. So if you make more than 50% of construction workers, then you've made more than, looks like 75%, because that's Q3, right? So this is Q1, this is the median, this is Q3, right? This is Q1, this is the median for the teachers, and this is Q3, right? So the median for construction worker is Q3 for teachers. So I'm going to go 75% on that. Okay, how much do you need to make in order to make more than 50% of all teachers? Okay, let's see. So how much do you need to make in order to make more than 50%? Well, what's the median for teachers? The median for teachers is 35. So you need to make more than 35,000, okay, to say that I make more than 50% of teachers. Okay. How much do you need to make in order to earn more than all the teachers and construction workers? How much do you need to make in order to earn more than all the teachers and all the construction workers? Well, it looks like we're to earn more than all the teachers and well, it's more than 50,000. Okay, because all the construction workers are right here. That's the maximum for a construction worker. And I didn't really know, but I would say I'm going to go 55,000. Okay, because look at if you look at the spacing here, there's this, right? And then if I were to go to the next spacing from 45 to 50, 50 to 55, I'm going to say to be safe, I'm going to say 55K. Okay, to earn more than any teacher or construction worker. Okay. Okay, if you had to choose one of careers above based only on salary, which would you choose and why? Well, obviously, if you want to make more money, you would choose the construction worker. Okay, I'd choose construction over teaching. Okay, let's go to our final page here. Okay, John is an actuary and makes more than 50% of his makes more than 50% of his peers. Okay, so his other actuaries. So where's the 50th percentile for actuaries? It's right here. Okay, so John is making, I don't know, 75 grand a year. Okay, Jemima is a CPA and makes more than 75% of her. Oh, okay, so they're making the same amount of money. She earns the 75th percentile. Who makes more money? Okay, John, Jemima, or do they make about the same salary? Okay, so the actuary here, John is the 50th percentile. The CPA is 70, so I'm going to say they make about the same. Okay, about the same. Okay, B, someone who makes more than 25% of actuaries will make what percent of CPAs? More than 25% of actuaries is here. This is the 25th percentile for actuaries. And CPA is 50th percentile, right? It's the middle, the median. So, okay, again, you can label these Q1, median, Q3. This is Q1, median, okay, Q3 for the actuaries. Okay, and so the 25th percentile is the 50th percentile for, okay. Okay, is the 50th percentile, 50%. Okay, for her. Okay, other practice. For each data set below, find the 5-number summary. Okay, wow, that's a big data set. There are 117 values in this data set. Okay. Use the percentile locator method to find the quartiles and if there's odd number of values. Okay. So find the 5-number summary. Okay, so use the percentile locator method. Okay, so looks like the values go from, are they arranged in order? I hope they are. Go from 12.2 to 54.6. Nope. Doesn't. Plus they give me an extra number. Oh, so these are, I think these are 100 and, let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 117, 9 by 13. Is that true? 9 times 13 is 117, yeah. Oh, okay, these are two different, these are two different, I didn't see the A and B here. Okay, we'll get to the B in a minute. Okay, the A is just these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. Okay, so that's going to be a lot easier. Okay. So let's find the 5-number summary. Okay, so let's look at just these 10 values here for the 5-number summary. Okay, this guy is the minimum. This guy is the maximum, just for A. Okay, what's the median? What's the median? Well, it's going to be the average between 14.4 and 19. Okay, so if we were to average 14.4 and 19, that's going to be the median. So the median, 14.4 plus 19, divide that by 2, I get 16.7. Okay, so that's the median there, is 16.7. Okay, so the minimum is this one, the maximum is that one. So the minimum is 4, I'll just write these numbers out. 4.8 is the minimum. The median is 16.7, because it's the average of these two. The maximum is 29.7. Okay, so what's Q1? Well, Q1's pretty easy. It's the middle of the lower half, because we have an odd number of values now. So Q1 is 11.1. Okay, and Q3 is going to be the middle of the lower half, which is this guy here. So that's 26.9. So there's my 5-number summary. Oops. Let's try that again. Okay, so that's for part A. That's my 5-number summary for part A. Let's go to the part B. Okay, for part B. Okay, so let's try this guy. There's 117 values. Okay, so this is a lot. So the min and max, that's going to be easy. Here's the max, here's the min. Okay, but now let's find the median. Let's find the median. The median is going to be, it's an odd number of values. So what I can do is I can cut this number in half. Okay, I can subtract 1 from this number and cut it in half. Why can I do that? Because if I were to think of this as being a balanced, right, you're going to have one, if it's an odd number, you're going to have one data set in the middle, and then you're going to have the same number on both sides. Okay, if it's an odd number for the median. So what I can do is I can say, okay, I'm going to subtract off the median, which is the median data set, which would be one data point. And then I'm going to say, oh, I'm going to have 116 left over, right? I'm going to have 116 left over, and they have to be evenly distributed on both sides. So 116 divided by 2 is, I believe, 58. Okay, so there's going to be 58 values over here, 58 values over here, and there's going to be 1 value in the middle. Okay, and that's going to give me, so the 59th value, here is going to be my median. Okay, so the 59th value is going to be my median. Okay, so what's that going to be? So again, I have rows of 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So rows of 9, and I know that 9 times 6 is 54. So let's go down 6. 1, 2, 3, 4, 5, 6. So this is my 54th, 55th, 56th, 57th, 58th, 59th. Look at that right there. I'm going to erase the other ones. Boom. And so my median ended up being 34.7. Okay, so that's my median. So I have my minimum, I have my median, and I have my maximum. Okay, so the lower half has 58 values, right? So the lower half has 58 values. So what I can do is I can cut that in half. Those 58 values, I'm gonna cut 58 in half. So 58 divided by 2 is 29. Okay. So what I'm looking for is I'm looking for 29 on one side and 29 on the other. So it'll be 29 and 29. However, because it's even, I have to get the 29th and 30th value. So what's the 29th? Well, this is 27. This is 28, 29, and 30. And look at that. 29 and 30 both have the same value. So that's Q1. Q1 is 29.3. Because I don't have to average them. The average is them. If you add up 29.3 and 29.3 and you divide by 2, I get my Q1 that way. Okay. Okay, now what's the other 58? The top 58. We don't include our median. Our median is not included. But after our median, we have 58 numbers. So again, I'm going to do the same thing. I'm going to go up 29 from here. And so that's not going to be as easy because I'm starting at the 59th value, but I'll just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So here's these guys. This is the 29th and 30th values. Okay, so the 29th and 30th values there. Okay, is that right? Did I do that right? Okay, so 40.1 and 40.2. Let me just make sure. Let's do it from the back. Let's do 20. Let's do 29 from the back. Okay, so this is 29. So this would be my 27th, 28th, 29th, yeah. And then the 30th, yep. So it's those two. So we're going to average those two. 40.1 and 40.1 and 40.2. Well, if I add those up and divide by 2, I get 40.15. So that would be Q3. So my Q3 here, let's write this out on the bottom here. My min was 12.2. I'm just going to write them in order here. My Q1, the min was 12.2. The Q1 was 29.3. The Q2, or the median, was 34.7. Okay, the Q3, okay, my upper quartile is going to be 40.15, and my maximum is at 54.6. 54.6. Okay, so now it says, using the data set from 4A, find the 30th percentile. Okay, so what's 0.30 of 10 items? Well, that's 3, okay? And remember, when we got in a whole number, we did the average from the third and the fourth number, right? So this would be the average of the third number and the fourth number. And we got a whole number and the fourth number. So that's going to be 11.2 and 11.2. Oh, sorry, 11.1 and 13.2. So 11.1 plus 13.2 over 2. Okay, so let's go to our calculator on that one. 11.1 plus 13.2 divide by 2 is 12.15. So that's 12.15. That's the 30th percentile for the first one. And the second data set, we want the 45th percentile. Okay, so for the 45th percentile, that's 0.45 times 117. So 0.45 times 117 is 52.65, and we go up to the next one. So this is 56.25, which means that we go, that's a 5, which means that we go to 57, the 57th item. Okay, so what was the 57th item? Well, we already know that the 59th item was the median. And so the 57th item should be right here, okay, which is 33.7. So that's 33.7. Oh. Okay. Okay. Thank you very much for watching and taking notes. And you know, if the videos get too long to do in one setting, then don't do them in one sitting. You know, take breaks. Do yourself a favor, and you know, get up, pause the video, then come back. Okay. You know, it's very the most effective studying strategy is to study for 45 minutes, take a 15-minute break, and then come back, and then do another 45 and 15 minutes. Okay, and then don't do that for more than 4 hours at a time. Okay, but if you're gonna sit down and do something, work on one thing for four hours, that's the most effective way that it's been shown. 45 minutes, and come back and then take a 15-minute break and come back. 45 and come back. Okay, because I don't want you sitting here watching this for an hour and a half, and then you know just tune out after the first half. Okay. Okay, I will see you in the next video, in the next chapters, 2.5 to 2.7 next time. Okay.